Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today I am going to explain about the rectifier definition, the types of rectifiers, in that single phase half wave uncontrolled rectifier. So now here the first definition, rectifier. Rectifier is an electrical device which converts from AC voltage to DC voltage by using diodes and thyristors. So here is the AC voltage. So AC means amplitude, and amplitude is changing with respect to the time, and here for the DC the amplitude is constant. So now here to convert from AC to DC we are using here the rectifiers. So now here what are the advantages and disadvantages of rectifier? Rectifiers are a simple type of rectifiers. So as they consist of at least a few basic fundamental components, and next they are cheap and easy to use and construct. We can easily construct and we can easily use that rectifier, and they are used in both half cycles of input voltage, so which results high efficiency, and if low power losses means high power, high efficiency. And next here it produces the high amount of output voltage in the DC as compared to the half wave rectifiers. And next, what about the disadvantages? And now here the wastage of energy, half of the energy, and low utilization factor, and it produces the low output voltage. And next here these rectifiers are complex as compared to the other rectifiers and large number of components. So now here these are the applications. So they are used in the powering application with the transformers, and used in the soldering. So now here the types of rectifiers. Here what are the types? So here based on the number of pulses, the rectifiers are divided into different types. So here this is one pulse, and this one is a 2 pulse 2 pi, and this is a pi 2 pi. And now here within one, this is 2 pi, and now here 3 pulse, and now here within 1 2 3 4 5 6 pulse. So 1 pulse based on the number of pulses, 2 pulse, and 3 pulse, 6 pulse. So 1 pulse converter we will get in the half wave rectifier, single phase half wave rectifier. And 2 pulse rectifier, 2 pulse rectifiers we are getting in the full wave rectifier, single phase. And the 3 phase half wave rectifier we will get, and 3 phase full wave rectifier we will get 6 pulses. So now here how we will get? So here if you give the AC supply, and you will get the DC supply. So here fixed AC to fixed DC in case of uncontrolled rectifier. So here we will use only diodes. And next here fixed AC to variable DC. So here we will use variable thyristors only, fully controlled rectifiers. And next semi-controlled rectifier means here we will use diodes and SCRs and diodes. So variable AC and fixed AC. So now here if you see this diagram, so types of rectifiers, there are 2 types, single phase rectifier and 3 phase rectifier. In the single phase rectifier, half wave rectifier, full wave rectifier. In this also same half wave rectifier, and here 1 pulse only, and here 2 pulses. Here 3 pulses, here 6 pulses. And now here uncontrolled rectifier and controlled rectifier. In that, these are different types of loads. Now here, uncontrolled full wave rectifier, controlled full wave rectifier, and semi-controlled rectifier. These are the loads. So now here in the uncontrolled rectifier, we will use only diodes. So in the controlled rectifier, we will use here thyristors. So here is also diodes, thyristors, and here thyristors and diodes in the semiconductor devices, thyristors and diodes. So this now here we will get the fixed DC, and here variable DC, and here variable DC. So these are the types of classification of rectifiers. So in this, first I will explain uncontrolled rectifier with RL load, then RL load and RL with freewheeling diode, then RE and RLE type of load. So first I will explain single phase half wave uncontrolled rectifier with R load and RL load. So first here I will explain single phase half wave controlled uncontrolled rectifier with R load. Uncontrolled rectifier with R load. So first here uncontrolled rectifier means here we are using the diode. I am using diode. So first one is the diode. Supply voltage I am giving to the diode, and now here load R load I am taking. So now here V0. Now here this is the I0 output current. So now here how it will the voltage waveform. First, if you give the positive voltage supply, this is I am going to give the supply given to Vs equals to Vm sin omega t. So this is the Vm sin omega t. This is the maximum value. So here 2 pi, up to 2 pi. So up to here time period 2 pi. And now here I am giving this AC sine wave to this diode and load. So first what will happen? So when anode is positive, this is diode anode and this is the cathode. When anode voltage VAK is greater than VK, then this diode will conduct. So the diode is in forward bias condition. So now here it will be acts as a short circuit. So now same output voltage is developed across the load. So this output voltage is here only. And now here what about the current? V0 equals to Vs only when Va is greater than Vak. So diode is in forward bias condition only. So now in the second case, so VAK, so the VK is greater than cathode voltage is greater than anode voltage. So now here output voltage equals to 0 because it is a open circuit. In the open circuit condition, so the this diode voltage is 0, and now here output voltage is 0. This output voltage equals to 0, and now here the diode voltage is a Vs. So the diode voltage is a Vs. Now what about the current? Current equals to I0 equals to V0 by R. It will follows the supply voltage. So but this voltage is V0 by R. I0 means. The diode voltage is here short circuit during the forward bias condition. During the reverse bias condition, this is forward bias condition. This is the reverse bias condition. Let me explain you again. So first here during forward bias condition, so anode voltage is greater than cathode voltage. Now here the diode is acts as a short circuit. And now here the diode voltage is 0. And this output voltage is developed across this supply voltage is developed across the output voltage. So V0 it is a voltage strip type of load. So this output current follows the supply this voltage. And now here this output was same voltage developed across this Vs equals to V0. What about in reverse bias? In the reverse bias condition, So the output voltage is 0. The output voltage is 0 because it is an open circuit. So open circuit condition, output voltage 0. It is a voltage type of load, means that is R type of load. In that case, the voltage is 0. Current voltage 0 means current is also 0. Voltage divided by resistance. But here this open circuit voltage is the this diode voltage is the Vs. This voltage is developed across here. So now here, how you will determine this output voltage, this V0 RMS value, V0 average value, V0 average equals to, how you will, this one equals to total time period divided by 0 to pi. So total time period is up to 2 pi. So here total time period up to 2 pi, output voltage V0 average equals to, it is conducting up to pi only, 0 to pi. So Vm sin omega t. Vm sin omega t. If you simplify this one, so this equals to Vm by pi. V0 average equals to. First question. And second question is, so now here I0 RMS equals to, if you simplify this one, 1 by 2 pi integral of 0 to pi, this is Vm. So sin omega t means that is cos omega t minus cos omega t. And now here cos phi is my cos pi minus cos 0, that is 2, 1 minus 1 minus 1. So that is 2 gets cancelled, Vm by pi only. So now here V0 average divided by R, so that equals to Vm by pi R. So this is a case for RMS value, average value. Sorry, this is average value of voltage, output voltage for 0 to pi, and average value of output voltage. And now here second case, this is uncontrolled rectifier. And now here second case, now here, so now in this case, first here is also same, this voltage is, this voltage equals to, this voltage equals to, this voltage is, this voltage equals to, this voltage is uncontrolled rectifier, this one average value we have discussed, and this one and this one, RMS value equals to, V0 RMS equals to, how you will get calculate. So first one is so here 1 by 2 pi integral of 0 to pi Vm sin square omega t. If you simplify this one, that is Vm by 2 only, V0 RMS. So now here I0 RMS equals to V0 by 2R, means V0 RMS by R. So this is equation number 3 and this is equation number 4. So now here this is the output voltage. So now here what about the output voltage? P0 equals, fifth question, P0 equals to, so V0 RMS into I0 RMS. And now here V0 RMS square by R and I0 RMS square into R. And now here third sixth question is input power factor equals to Vp input equals to P output, that equals to P input equals to Vs Is cos phi, that equals to V0 RMS square by R. So here you can write it as a I0 RMS square into R. So Is I0 is same in case of voltage type of load here. So now here I0 RMS into R means that is V0 RMS by Vs is the input power factor, that is a cos phi. And now here what about the peak inverse voltage? This is seventh question is what about the peak inverse voltage? Is the PIV is the Seventh question is a peak inverse voltage is a minus Vm. So that is minus Vm. And next eighth question is gamma of D equals to gamma of D. It is conducting up to pi only. It is conducting up to pi only. And what about the extension angle is also pi up to pi, and the time up to what angle the diode is conducting. And now here what about the circuit turn of time? So the circuit turn of time, this is 9th and this is the 10th, the time for which the diode is in reverse bias. So here this is pi to 2 pi, the diode is in reverse bias. In that case the diode voltage is Vs, so that is up to pi angle. This diode is in reverse bias, Tc equals to pi by omega. So now here we have discussed V0. First question is V0 average value equals to Vm by pi. Second question, I0 average value equals to Vm by pi r. And next third question is V0 RMS equals to Vm by 2 and I0 RMS equals to V0 by 2 or Vm by 2r. And next here fifth question is the output voltage, input power factor, and peak inverse voltage is minus Vm, and diode conduction time is pi, and extension angle is up to, the diode is conducting up to pi. And what about the circuit turn of time? Pi by omega. So now here this is uncontrolled rectifier only. So now here uncontrolled rectifier with L load. So in case of L load, first one is so if you see this one, if you see the diagram, so here I am giving the supply voltage V equals to Vm sin omega t. So here when during forward bias condition, so Va is greater than the VAK. So Va is greater than VAK, V cathode voltage. So the diode is in forward bias. And now here in this case, so diode follow the output voltage follows the supply voltage, V0 equals to Vm sin omega t. So now what about the current? So current equals to V equals to L di by dt. So that equals to Vs equals to Vm sin omega t. And now here, so L di by dt means Vm by pi, Vm by omega L. So I equals to I of t equals to, so 1 minus cos omega t. So now here the output current is increasing like this up to pi only. And after pi, so the diode is in reverse bias, Vk is greater than Va. So diode is in reverse bias. Diode is in reverse bias. And now here in this case, output voltage equals to V0. So here output voltage equals to same Vs equals to V0 only. So now here that it will follow the supply voltage, but this current will decrease. So but diode voltage is always short circuit. In the reverse bias condition also the diode will be conduct. So how it will be conduct? So we know very well about inductor property. Inductor store the energy in the form of magnetic field. So during positive half cycle, so it stores the energy, and during the negative half cycle, so here it will delivers the power to the from the load to the source. So now here in this case it will deliver the power is delivered to the source, so the current will decreases. So now here this is the current waveform. So now here this current waveform equals to, here the maximum value equals to here Vm by 2 Vm by omega L. This is a Vm. And now here the diode voltage is always 0. So now here V average value, so it is a symmetrical waveform, V average equals to, for any symmetrical waveform V average value equals to 0. And what about the current waveform? Second one, I average equals to, so Vm by omega L. And now here third one is a V0 RMS equals to, here V0 RMS, this is a uncontrolled rectifier, V naught RMS equals to, so now here 1 by, so this voltage is up to here. So now here 1 by 2 pi 0 to 2 pi Vm sine square omega t. So now here this is the output voltage. So that is Vm by root 2 V naught RMS. So now what about the extension angle? So conduction time gamma of d equals to 2 pi. It is conducting up to 2 pi and extension angle is 2 pi up to. So here this output voltage, output current is, it is always all time the diode is conducting. And now here is there any peak inverse voltage? Peak inverse voltage is now here Tc equals to 0. So is there a diode is always conducting, there is no reverse bias case. So the circuit turn of omega Tc equals to 0. So now here Tc equals to 0 only. So now here all these are the cases for single phase off wave controlled uncontrolled rectifier with R load, L load and RL load.
Like, share and subscribe. Hit the bell icon for more updates.